today we are going to discuss trusses. So let us first try to understand what is a truss. Now you must have come across this concept in your day-to-day life. Like for example, you must have seen a mobile tower or an electric transmission lines, or maybe roof girdles. A typical mobile tower may look like this. There will be things like, or there can be a roof girdle in this fashion. You can have such situations in your day-to-day life, and these are known as trusses. Now there are a few things which you need to know about a truss. Number one, all these truss, the structure truss is coplanar, that is it lies in one plane. So this entire thing is coplanar. These are known as the joints. For example, this particular point, they are known as joints, and their joints are interconnected by rods. So AC and AB, they are like rods, and they are known as members of the truss. So what we have is joints. These are called as joints, and AB, AC, BD, BE, BF, etc. they are known as members. Now there are a few things which we must keep in mind. There is a particular protocol that must be followed while solving the problems on truss. So first of all, we must be aware of certain things before we actually start solving the problem. Let us again redraw a typical truss. I'm just taking an example. Say this is A, B, C, D, E and F. So as I have discussed previously, points A, B, C, D, E, F are known as joints, whereas AF, AB, BE, BD, etc. they are known as members of the truss. All these members, which are basically rods or beams, they are lying in one plane. So it's a plane truss. Second thing is, the truss is supposed to be in equilibrium. That is, the equations of equilibrium can be applied while solving the problems on the truss. This truss is connected to the ground by three types of supports. There are three types of supports. The first kind of support is known as a hinged support. Its symbol is this. It has got a vertical as well as a horizontal reaction. Please note, the vertical and the horizontal reaction can be upward also, it can be downward also, it can be to the right also, it can be to the left also. So this is a hinge support. The second kind of support is known as a roller support. It is indicated by this symbol. It is just like a skate, and it has got only a vertical reaction. It can be either upward or it can be downward. The third kind of support that we may come across, which we come across very rarely, and that support is known as A fixed support. A fixed support is like a nail hammered into a wall. A fixed support has a vertical reaction, it has a horizontal reaction, as well as it has a moment. However, this fixed support we will come across very rarely. Very rarely. In most of the cases, we will have a vertical, we will have a hinge support and a roller support. These are the two important supports that we will normally come across, a hinge support and a roller support. A fixed support will be very rarely, we will come across it very rarely. Now these supports are always attached at the joints, so the supports are always going to be attached at the joints. For example, at this particular point we may have a hinge support, at this particular point we may have a roller support. In most of the problems, one of the supports is hinged and the other is roller. Again, very rarely we will come across two hinge supports in the same truss. Okay. Now the loading. This particular truss will be under loads, and the loads will always be acting at the joints. For example, there can be a load of say 100 kilonewton at this joint. There can be a load of 50 kilonewton at this joint. But please remember, the load will always be at the joint. It will never happen that a load is applied somewhere in between. It is not possible. The loads will always be at the joints. It can be anywhere at the joints, but it can never be in between. Load is not possible in between, right? Okay. Now the members, all these members of the truss, suppose again let me redraw the truss. These members of the truss will be under force, will be under some kind of force. This force can be either tensile or it can be compressive. For example, let us consider the member AB. If the force in the member AB is tensile, while drawing the free body diagram of joint A, it will be shown away from AB. Whereas, suppose the force in the member AC is suppose compressive, then while drawing the free body diagram of joint A, a compressive force will be shown towards the joint, whereas a tensile force will be shown away from the joint. Please note that we have to draw free body diagrams of each joint separately in order to solve the problem on the truss. Each and every point must be considered separately while drawing the free body diagram. So let us take an example that force in the member AB, say let us take FAB is 100 kilonewton tensile. Then if we draw the free body diagram of joint B, the same force will be shown away from B. Whereas while drawing free body diagram of joint A, the same force, since it is tensile, it is away from the joint and it will be shown in this fashion. Please note whether it is AB or BA, the value of the force is still 100. Just look at the directions. For free body diagram of joint A, for a tensile force it will be away from A. The same tensile force at B will be away from B. So this also needs to be kept in mind. Before solving the problem, we do not know whether the force is tensile or compressive, so we will always assume that the force is tensile. After solving the equations, if the answer comes out to be positive, then our assumption is correct. But suppose our answer turns out to be negative, for example FAB turns out to be minus 100, then it means that instead of tensile the force is compressive, that is its direction is reversed. So what is the protocol in solving the problem on a truss? The first thing to do is to use geometry. Use geometry and find all possible angles and all possible lengths. This is the most important thing that we must do. That as point number 1. Point number 2, what do? We find the support reactions. If you can recall, at the hinged and the roller support, and then we apply the third step, that is find forces in members. By drawing FBD at each joint. Now while drawing FBD at each joint, we must be very careful. In that sense, choose a joint with least number of forces. The best will be with only 2 members. That will be the best way of solving the problem. Now there are 2 ways of solving a problem. One is known as method of joints and the second is method of sections. First we will consider a method of joints and then we will consider method of sections. In the exam, the problem will be asked to be solved using both the methods. So we must master method of joints as well as method of sections. Let us go through the protocol one more time. First is use geometry, find all the possible angles and all the lengths of members. Number 2, find the external support reactions of hinged and roller support. Number 3 is to find the forces in members either by method of joints or by method of sections, as the problem may be. But for that, you must choose a joint with 2 members first, and then we proceed with the joints containing more than 2 members. So now let us take an illustrative example and try to solve a problem. We are supposed to find the forces in all the members of the truss that I am going to draw here. Please copy this in your notebook because we will be needing this. I will have to erase from time to time. This is a hinge support here. Here we have a roller support. This is A, D, E, F. This is C. And this is B. There is a load of 25 kilonewton acting vertically. This is a 90-degree angle. And there is a load of 15 kilonewton again acting vertically in this line. This length is 3 meters. This D is also 3 meters. EF is also 3 meters. And its vertical distance is also 3 meters. So this is the load. This is a truss. We have got a 25 kilonewton member here, a 15 kilonewton force here. AD, DE and EF are all 3 meter, 3 meter, 3 meter. The vertical distance is also 3 meter. This is a hinge support and this is a roller support. So this is our problem. So please take down the problem carefully so that I can elaborate how to resolve the forces and how to find the reactions. First we are going to use the method of joints, and then we will do the method of sections. As I had discussed earlier, this truss is in equilibrium, so we are free to use three equations. The first equation is sum of all the forces in the horizontal direction, that is x-axis, must be 0. The second equation is sum of all the forces in the vertical direction, that is y, is 0. And the third equation is that sum of all the moments about any point is 0. Please note that you can take moment about any point in plane and still it will be 0. You can take moment about any point in plane and still it will be 0. We have to use sign conventions. For example, while taking moments, you can decide clockwise moment to be positive and anti-clockwise to be negative. For fx, you can consider right side positive, left side negative. For sigma fy, you can consider vertically upward as positive and vertically downward as negative. So first thing, if you recall the protocol, is use geometry and try to find all the lengths. So that is what I am going to do first. I am going to use geometry to find all the lengths. So let me erase this. Give me a second. I hope you have your calculators ready with you. We need a good scientific calculator with an equation mode which will enable us to solve 2 or 3 equations simultaneously. So please have a good scientific calculator of Casio, maybe from the FX series. You can also have a very nice scientific calculator downloaded from Google Play Store. That will also work fine. So let us first find various lengths. I need to find the length AB, I need to find length BC, I need to find length BD. So various lengths I need to find. So let us first try to find this angle. See, this is 3 and this is 6. So if I redraw it here, this is 3 meter, this is 6 meter. So this tan theta will be 0.5. That gives me theta as tan inverse of 0.5. If you calculate the value of tan inverse of 0.5, you can just calculate it, just check it. It turns out to be something like 26.6. Please do the calculation and confirm. Right, so it is 26.56 or 26.6. Now let us try to find length AB. Just try to find length AB. For that we will use cos. Again, look at the triangle ABD and we have cos 26.56 as adjacent side, which is 3 upon hypotenuse AB, and that gives me the value of AB as 3 upon cos 26.56. Please find it out. It turns out to be 3.35. Just see if we have this 3.35. obviously BC also will be 3.35 because it goes by symmetry. So BC also will be 3.35. So we have got these two values ready with us. Vertical line we know. Let us try to find BD, and it may not be required, but still you can find the value of BD. And I think it goes with geometry that you can look at the triangle ACE. ACE and ABD are similar triangles. So obviously if C is 3, BD will be half of 3. So BD will be 1.5. You can actually check it out. No problem, you can check it out, and it will be 1.5. So now we have got lengths ready, and now we are ready to solve the problem using the equations of equilibrium. Let me redraw the entire figure for you. So we have situation here. Excuse me. We have two forces. For the time being I am showing only one force. Let me draw a horizontal line. Let me draw a vertical line. This particular angle and this particular angle are corresponding. So this angle also will be 26.6, and this angle over here, this angle will be 63.4, that is 90 minus 26.6, it will be 63.4. I have got one support which is a hinge support, so I have got two reactions, say VA and a horizontal reaction HA. At this particular point, which is point F, there is a roller support, so I have got only one reaction, and that is vertical reaction VF. Now I have, let me redraw a situation again for you. I have a 25 Newton force making an angle of 63.4 with the horizontal. It will be resolved into two components. One is horizontal, that is 25 cos 63.4, and the other will be vertical, 25 sine 63.4, and same goes with a 15 Newton force here, exactly same. So now let me draw all the forces only in the horizontal and vertical direction. Let us not bother about the main diagram. Let me draw all the forces separately for you to have an easier understanding. So what do we have here? We have one force which is horizontal, 25 cos 63.4, and then we have a vertically downward force, 25 sine 63.4. On exactly same way we have 15 cos 63.4 and 15 sine 63.4. We have VA, we have VF, and we have HA. Now let us apply that sum of all the forces in the vertical direction must be 0. So upward forces must be equal to downward forces. So what do we have? Is VA plus VF will be equal to 25 sine 63.4 plus 15 sine 63.4. Please do this calculation, and we have our first equation ready, that is VA plus VF, and it turns out to be 35.76. Please make sure, please do the calculation and make sure you get VA plus VF as 35.76. Now let us find the horizontal. Let us find the horizontal force. Obviously, as both these horizontal forces are to the right, HA will be to the left. So HA will be a sum of 15 cos 63.4 plus 25 cos 63.4, and let's see, we will get this answer as 17.9 to the left. So now I have got HA, which is 17.9 kilonewton to the left. We also have VA plus VF as 35.76. Please keep these values ready. And now the next job is to find the moments. That is going to be slightly tricky. I am going to explain this concept of finding the moments in detail. So let me again redraw various forces so that we can understand this very clearly. There is one force of 25, there is another force 15, there is one force over here which is VF, and there are two forces over here, VA and HA. This is point A. This distance is 3.35. This distance is also 3.35. Please note that both these angles are 90 degrees. Now I am going to take the moments about point A with a sign convention that a clockwise moment is positive. Now a moment is force multiplied by moment arm, and a moment arm is a perpendicular distance between the line of action of force and the point about which you are going to take a moment. For example, this is the line of action of force, so obviously this is the perpendicular distance, which is 3.35. So the moment of 25 Newton about A will be 25 into 3.35. You can see that it is clockwise. Imagine that you are driving a car in this direction and you want to go to A, you will take a turn which is clockwise. So 25 into 3.35 will be clockwise, so it will be positive. 15 into 3.35 plus 3.35, that is 6.7. That also will be positive because it will be clockwise. This total distance, if you recall from the diagram, is 9. So when you take VF into A, you can see it will be anti-clockwise, and so the total moment of VF about point A will be VF into 9, and that will be anti-clockwise. So what is the equation that we have? The equation that we have is 25 into 3.35 plus 15 into 3.35 plus 3.35, that is 6.7, minus VF into 9 is equal to 0. If you do these calculations, please do the calculation and see the value of VF, what you are getting. The value of VF will turn out to be 20.5. Please do this calculation and make sure what value of VF you are getting, it must be 20.5. Alright, okay. So now as you get VF as 20.5, our job is done. Please recall that VA plus VF we have already calculated as 35.76. It was already calculated. In that, if you put VF as 20.5, you will get the value of VA as VA plus 20.5 equal to 35.76, and that gives you the value of VA as 15.3 approximately 15.3. So now the first part is over. We have calculated all the support reactions. So let us tabulate the result. You also tabulate the result in your notebooks. What we have here is HA is 17.9, and that is to the left. We have VA as 15.3 upwards. We have VF as 20.5 kilonewton upwards. So with these results, now we are going to proceed to the method of joints to find forces in all the members. So let us first go to the joint with least number of members. You can recall the diagram. Either we can go for joint A or we can go for joint F. So let us go for joint A first. So we have a joint A here. Let us assume that in the beginning that both the members are inside. So we have FAB, we have FAD, we have a vertical reaction here VA, which we already computed as 15.3. We also have a horizontal reaction HA, which we have computed as 17.9. We know this angle as 26.6. Let us now do sigma Fy is equal to 0. So we have FAB sine 26.6 in the upward direction plus 15.3 equal to 0. Solve this equation and you will get FAB as minus of 34. Please do the calculations and see what you get. Around 34.2 we are getting. Please don't change the negative sign, let it be as it is. Unless and until we will solve the entire joint, do not change the negative sign to positive. But please note that we have assumed FAB to be tensile going away from the joint. As the answer has come negative, actually it is compressive, but we will do that later on. Right now let us keep this value as it is. Now let us do sigma Fx equal to 0 with the convention that right side positive. So we have minus 17.9 plus FAD plus the horizontal component of FAB, which is FAB cos 26.6. Sum of all these things will be 0. You can put the value of FAB as minus 34.2, and what you will get is minus 17.9 plus FAD minus 34.2 cos 26.6 equal to 0. Solve this to get the value of FAD. So please solve this and see what value you get. That is 17.9 plus 34.2 into cos 26.6, and you get 48.4. So the value of FAD is 48.4. Please see, as the value has turned out to be positive, it means FAD is tensile and our direction is correct. Our direction is correct. Fine. Now we are going to go towards our next joint. Please note that let us choose the next joint as F, or you can choose the next joint as D. I think joint F you can do on your own, so let me do joint D for you. Let us consider joint D. What are the forces at joint D? I got a vertical force here, which is FDB. Then one force is to the right, which is FDE, and one force to the left, FAD, which we have already computed as 48.4 tensile, so it is away. So it's obvious that since this dB will not have any component in the horizontal direction, D and 48.48 will exactly be same. So FD will also be equal to 48.4. As there is no force acting over here, FDB has to be 0. So it's a 0 force member because there is no other vertical force to match this. So FDB has to be 0. So in this way, you can find FDB and FDE. Now other joints we can also easily find in a similar way. Please try to find the values of the remaining forces. Maybe let us do one more joint which seems a little complicated. We can go for joint B. Let us try to go for joint B and find, but it is just a resolution, so we should be able to do it very easily. Let us try it out. Let us go for joint B. This is joint B over here. It has got a 25 kilonewton force. The angle is over here is 63.4. This particular force is FBC. FAB we have already computed, and FAB is 34, but it has compressive. Compressive means it will be towards the joint, so it will be towards joint B. So it will be in this direction. We have 34 kilonewton in this direction. FBD, which is vertically downwards, is already 0, so we need not bother about this. So we have got only 3 forces. One is BC, one is this 25, and the other force which you already computed is 34. Obviously this angle also will be 26.56. so let us now go for sigma fx, sigma fy, and we should be able to get the answer. Let us go for, I think we need to find only one equation, that is sigma fx. So let us do this. We have FBC cos 26.56 plus 25 cos 63.4 plus 34 cos 26.56, and that is 0. If you compute this, you should be able to get the value of FBC. If it turns out to be negative, please do the calculation and see what value of FBC we are getting. Please do the calculation. I'm getting 46.5. Please do the calculations and see what you are getting. And in this way you can solve many problems on the truss. Please make sure that you do not make any silly mistakes here. Please do the calculations and see what answer you are getting. Cos 63.4 plus 34 cos 26.56, that is 41.6. So we are getting 41.6 upon cos 26.56. And the answer I am getting is something like 46.5. So I think that should be enough for the method of joints. We can go ahead with the method of sections in our next part. Thank you.